Good morning, everyone. My name is Justin Walford. I am responsible for the Sprint marketing, and my colleague Paul Moore on the right here is head of our application team. And today we're going to be delighted to show you our new and exciting technology, the Sprint system. Sprint is a new, game-changing contact scanning system for CNC machine tools, targeted at very specific applications initially, but it provides new methods of on-machine process, control, and capability. It's aimed at measuring parts on the machine, scanning at very high speed, at up to 15 meters per minute, and providing exceptional accuracy of the parts being measured, and bringing new capability to process control. The Sprint system scans along a pre-programmed path and records deflections from the path. These deflections are then synchronized with machine position data to give true 3D point data of the measurement part. And this is one of the unique parts about the system. No other system is giving true 3D scanning data. It gives very high surface data density, 1,000 true data points per second, obviously providing a lot of data, which obviously leads to a very good understanding of feature form. Compared to traditional touch trigger systems, the scanning system can provide significant cycle time savings, better accuracy, and obviously a much increased data volume, which obviously gives you a much better understanding of your part. The system architecture consists of the OSP60 probe, which is a very robust probe designed for the harsh machine environment, designed for the harsh tool changes that it has to incur. It has an optical link to the OMM receiver. This provides us with a range of about 4.5 meters, although you can use multiple receivers to extend that range. We have an interface box which is synchronizing the probe data with the machine tool position data and sending all the data to our CNC plugin, which is a software that's running on the control, that's doing the analysis and the handling of the data. Externally to the system, we have our Productivity Plus Editor Pro software, which is the tool to create the cycles that are running on the machine. And this tool is needed for our prismatic part feature functionality. The Sprint system is targeted at high-value CNC machining, and it's targeted for process control. We released the functionality in 4 key areas. Firstly, our standard prismatic feature measurement functionality, which is the standard functionality of the system for measuring circles, arcs and planes. And then additionally, we have 3 specific application toolkits for very specific tasks. The first is a blade measurement toolkit. The second is a mill turn for highly repeatable diameter measurement. And the third is a very fast verification of machine capability, what we call a machine health check. Firstly, our prismatic capability. This is the standard functionality that's programmed through our software. This allows you to measure circles, arcs, and planes very fast, as they up to 15 meters per second, collecting 1,000 data points per second. This is our Productivity Plus Activator Pro software suite that we use to program the part, which generates the executables that can be run on the machine. Our CNC plugin that's running on the machine gives a live feedback of results and output, and data can be output to to other systems or output to log files for reporting. Whilst it's a scanning system, it can also do touch trigger tasks for setup tasks. But its big advantage is obviously the speed and the accuracy that it can collect data, and depending on the part that you are measuring, it can offer very significant cycle time savings. And this is one example of our prismatic part measurement, where we see about a 5 to 6 times cycle time saving in measuring these features. Our blade toolkit, the prismatic part measurement we will be showing in the demonstration area shortly after the presentation. Our blade toolkit, this is designed for performing blade tip refurbishment, root blending for bladed disc applications, and on-machine process control for blade manufacturing. It performs high-speed measurement and collection of blade sections, and it maintains high data integrity even on the leading and the trailing edges of the blade, which is obviously a key requirement these days. It's designed to be a drop-in replacement to an existing touch trigger system, but it offers significant cycle time advantages and accuracy advantages over the existing system. Here's some video of the toolkit in action. It goes through a series of stages and steps and tasks. We first carry out a procedure to locate the blade and align it by locating the edges. So-called edge find to align the blade and orientate it. We then measure the blade in 4 static orientations, so the 2 faces and the leading and the trailing edge. We take a number of sections which you are predefined, or you can define the number of sections that you wish to measure. Again, collecting a lot of data. And the data from these 4 static orientations, or patches as we like to call them, are then combined into one model, and we generate a surface through the model, and then we output points to your customers, to your specification, to the points that you need to have, either on the surface or the tip centers, and we output these to a reporting file, which can be then sent to your chosen CAD/CAM package for an adaptive process for a cut, measure, cut capability. Secondly, our MTM toolkit. This is our multitask machine toolkit. This is designed for very highly repeatable diameter measurement on Y-axis lathes. It has the potential to be a very accurate cycle, providing 1 to 2 microns of accuracy. The cycle works by having a reference ring permanently mounted on the machine, preferably somewhere near the part, preferably with the same material, so it has the same coefficient of expansion. And we take a measurement on this reference artifact prior to taking a measurement on the part, and this allows us to carry out a degree of thermal compensation on the part for when we're cutting the part to the diameter that we want to achieve. We recommend the use of coolant for better thermal stability, but in the video we're showing without coolant just so you can see it slightly better. So we've made a measurement on the reference artifact, and now we're making a measurement on the part. Notice that the probe is measuring the part whilst it's rotating, and the probe is also moving over the spindle axis. And it's the combination of this process that allows us to achieve the accuracy that we desire, and also allows us to separate out a number of components we'll see in a second. So from our own tests, we get plus or minus 1 micron repeatability. And from the processing, we output diameter, part run out, roundness, and the on-center error. So 4 parameters come out of the cycle. These are then loaded into the machine variables, and they can be then subsequently utilized in a cut, measure, cut process. Thirdly, the Machine Health Check Toolkit. This allows us to verify machine capability in less than a minute. It's designed as a very quick and simple go, no-go check prior to cutting a part. It consists of 2 tests, one for 3-axis machines and one for multi-axis machines. The test consists of having a magnetic artifact mounted on the machine with a known sphere for the 3-axis test, and then this cylinder with a cone drilled into the top of it for the 5-axis test. The health check cycle can be set up to be near automatic and can provide a daily health check on your system to monitor machine capability over time. So starting with the 3-axis check on the sphere, the probe first locates the sphere, then it takes a series of measurements, profile measurements across the sphere. Obviously, we're collecting a lot of data, 1,000 points per second. We get a very good understanding of the form of the sphere, and we can use this form to generate a form error that can be output to the machine variables and used as a tolerance check prior to deciding whether to proceed to cutting a part. It must be noted that we do not update the machine axis information. So this is an output that is just for you to decide whether your machine is ready for machining of the part. For the multi-axis machines, we drive the probe into the cone in the cylinder and then rotate the table in a number of orientations. As you see, the cycles are very quick. And once we've collected the data, we can calculate the pivot point error for the machine about the 2 rotation centers and output this information to the machine variables for checking. So it's designed as a simple go, no-go check in under a minute. Should the test fail, then we would recommend you move to a more comprehensive check, say a bull bar check, to obviously ascertain what it is about the machine that's causing it to be out of tolerance. So in summary, and obviously we want to show you the Sprint system shortly. So it's a new exciting technology. It's 3D. No other system is providing scanning data as true 3D data. Delivering high-speed, accurate data. The whole system is fully integrated into the CNC process, so we've had to work with Mazak to integrate the Sprint system to talk to the machine, to extract the machine position, so it's fully integrated. And it opens up new applications in terms of improving cycle time over touch trigger, providing lots more data, better accuracy, and leading to a better understanding of feature form. And this opens up new processes for on-machine process control and allows you to fundamentally rethink how you actually do process control with the high speed and the accuracy of the system. We believe it really is a game-changing system that will definitely in the future bring much benefit to the industry. Thank you.